Hello and welcome to Technical Utkranti, and today we are into the 19th question of the series, which is reverse pairs. So we have done all these questions till now, and this question is quite similar to question number 12 that we have done earlier. So I would recommend that you see that particular video as well. Let's move on to this question. So the question is that you are given an array and you need to find the number of pairs which obeys this particular rule over here. What is this rule? If number if in a pair a number lies before in an array, a real in an array, and if the number at that index is twice as great as the later number, then yeah, this would be called a reverse pair, which we need to find. So let's make it even simpler. So for example, 2 comes before 0 into 0, 2 into 0. So this forms one pair. Similarly, 5 comma 0 forms one pair. 7 comma 0 forms one pair. And then no such pair follows this rule. So how are we going to find all these pairs given the array? The array that we have is 0, 5, 7 and 2, sorry, 2, 5, 7 and 0, 4, 6, correct? This is 0. Yeah. So this is the array we have, and first brute force approach is that for each element I run a loop on the remainder of the elements and see that which of the pairs follow this particular rule, where this is I and the rest are j. And this I do for all the elements. So for 2, it is only 0 that will be following this particular relationship. For 5, again, it will be just 0. For 7, it will be just 0. And it will be happening for the entire array. Right? So in this, we get a time complexity of n square because there would be two nested loops and space complexity would be O of 1. Now, can we do better than this? We have an array which is totally sorted 1, 2, 3, 4, and 5. Now, tell me one thing, can you find any pair where the first element that comes is actually having this relationship with the second element, which means that the element lying earlier is greater than the element coming later? No, right? In ascending order, all the elements that come earlier will be smaller. So here, the number of reverse pairs that you will find will be 0. On the contrary, consider the case where it is reverse sorted, okay, completely. Here, you can see that always bigger element will come before the smaller element. In such a scenario, you have the maximum chance of finding reverse pairs, correct? Where reverse pair is given by this particular condition. Now, as you know, this is completely sorted and this is completely reverse sorted, right? In such a scenario, so what we'll have the input somewhere in between this range, correct? Now, the intuition is that whatever input that we get over here, we can sort it completely, and then in the process, we can find reverse pairs. So this is one intuition that we have to do sorting. All right. So the second, to understand how are we going to calculate the reverse pairs during sorting, let's take an example of a completely reverse sorted array, right? So what we'll do is we'll do merge sorting, and what happens in merge sorting is that there occurs the division of the actual array into sub-array. So we will have 5 comma 4 and 3 comma 2 comma 1. So this division will go on until we have array of length just 1. So this would be further divided to 3 comma 2 and this to 1, and then this will be divided into 3 and 2. Now as you can see, I have the array of length 1 finally at the end. Okay. Now what merge sort does is it takes sorted arrays, it takes two sorted arrays and then merges them to generate a bigger sorted array. Okay. Since the array of length 1 will be a sorted array because there is just one element, the sorting process begins from here. So this is 5 4. That's the problem with wrong handwriting. Okay. So here the merging happens and we get 4 comma 5. Correct? Okay. But 5 is not greater than 2 into 4. So the reverse pair count over here is just 0 for this level. We come over here and again after sorting it becomes 2 comma 3, and reverse pair count is just 0 because 3 is not greater than 2 times 2. Okay. Now similarly, now as you can see, this is a sorted array and this is a sorted array, and these two sorted arrays are merged to generate this sorted array. So how does that happen? But 2 is not greater than 2 times 1, correct? But if we compare it with 3 and 1, then we get one reverse pair over here. Okay. And after sorting, we get 1 2 3. Now we have two sorted arrays at this level, and number of reverse pairs we have found till now is 1. Okay. Now how are we going to calculate the number of reverse pairs at this level? The philosophy would be the same, but now we'll understand it in a much better way because this is a bigger example. Merge sort, we went up to very down level where only array of length 1 we found, and then we kept on merging and merging in a sorted way, and at the final level we have got these arrays. Okay. So let's call it left array and this you call it right array, and a pointer over here at the start is I and over here it's J. All right. Merging for sorting, and then secondly we look at how to count the pairs of A of I greater than 2 times A of J where I is less than J. Okay. So fine. I mean, both of them are quite similar only, but we look at them separately. What happens is I and J elements are compared. If the current element at right array is smaller than the current element in the left array, then this element goes over here and this pointer shifts over here. Again, I and jth elements are compared, and again we see that this one is smaller, so this comes over here and this shifts over here. Again we see that 3 is smaller than 4, then 3 comes over here, and then j goes out of the current array. Once any one of the array is exhausted, then the remainder of the elements of the rest of the array are just put in the same sequence, and hence we obtain a sorted array. So again, this is a left array and this is the right array. This is the ith pointer and this is the jth pointer. What we do is we compare if L of I is greater than 2 times R of J. So this is R and this is L. Okay. If this is the case, then the rest of the elements of the left array would be would be following this particular relationship, because further elements of the left array are greater than the current element of the left array. And if the current element of the left array is greater than 2 times the current element of the right array, then the rest of the elements would be greater than the current element of the right array in this particular, according to this particular equation. Okay. So what we do is we increment the reverse pair counter with the length of left array minus whatever is the current pointer of the left array, and then we increment the j pointer. Okay. Yes. Now we see that 4 and 2 does not observe this particular relationship. In that case, we increment the I counter and it comes to 5. Now 5 comma 2 observes this particular relationship. Okay. So again reverse pair counter is incremented. So in the previous case, reverse pair counter was incremented by 2, because both 4 and 5 were greater than 1, and in this case 5 is greater than 2, so again it is incremented by 1, and in that case this moves over here, and then 5 and 3 are compared. So 5 and 3 does not observe this particular relationship, so this pointer moves outside of the left array. Now when any of the array, either left or right array, is exhausted, then our calculation is over. So we see that while at the final stage of merging, we get 3 more reverse pairs, and initially we had 1 more reverse pair. Okay, while we were merging 2, 3, and 1, we get reverse pair of 4. Okay, now let's look at the code. Let's understand the code. Here we have implemented merge sort, and as you can see, I am passing this array 5, 4, 3, 2, 1. What this algorithm does is, until the length of the array is greater than 1, which means 2 or more than 2, then it will calculate the mid and split the array into left and right halves. Then it will recursively send the left and right arrays into this same algorithm, and then again split will happen, and this splitting would stop once we have reached that array of length 1, which we have seen previously. In that case, this return is encountered and the merging process from here onwards starts. So this is the merging algorithm which I have highlighted over here. And after that, it is the reverse pair counting algorithm that we saw. All right. So this is how reverse pairs would be calculated, and finally we'll get the answer. So let's have a look here. Yes, we get the number of reverse pairs as 4. So I hope you liked the video. If you did like, do give the thumbs up, and thank you. Bye bye.